Swayam Prabha. Digital India. Educated India.
Hello everyone, I welcome you all in the third week of NPTEL online course on laser based manufacturing. This is our first lecture of week 3. Till now in our previous weeks we have seen the fundamentals of lasers in the first week of this course, and in the second week we started using the lasers for cutting operation, for material removal operation. We have also seen how exactly the lasers are used in the industry by watching a video which is demonstrating the actual laser cutting of mild steel operation. Well, let's begin our lecture. This week we will be studying the various laser welding processes, their mechanisms, process characteristics, and their applications basically in the industry. This is week 3, that is a laser based welding as I mentioned, and today we are looking at the mechanisms of laser welding operation. Well, my friends, welding is an important manufacturing process. It is a fabrication process which is generally used to join the materials together for various parts, for various sub-assemblies in the product development. When we fuse or join two materials together, it may be similar materials or the dissimilar materials, by using a permanent join. So, in welding operation we are joining either similar materials or dissimilar materials, and the type of joint is permanent joint. In fabrication process we can join two different materials as temporary as well by using the fastening methods such as screws and nuts or rivets. However, when we fuse two materials together permanently, that is the welding process. So, how we weld or how we join these two materials together, we have to use the heat, thermal energy, and we use the pressure, or we use both simultaneously to join the two materials together, and then we get the bonding strong joint of two materials which is further being used. So, welding we can find everywhere around us in our domestic life as well, in the industrial life, in academic life, our furnitures, grills, construction purpose, everywhere we are using the welding. In a similar way, in manufacturing operations as well, we use welding very often. We can join metals and thermoplastics. As far as the industry is concerned, metals are widely used and there is need to join these metals. In the industry we are also using thermoplastics as well. So, there is also need to join the thermoplastics. So, we need to go for the welding operation. So, when we join these two materials together, in some of the cases we are using an additional material for fusing these two materials. We are using filler material. So, these filler materials are maybe of the same type or maybe the different type for joining these two materials. We generate a weld pool. So, weld pool is generated during the welding operation. A schematic is there in front of you. This is a very common process that we can see around. It is arc welding process. It is a metal arc welding process. It is used to join the metals together. So, to join this metal together we need to generate an electric arc. So, to generate an electric arc we need a power source. So, here we are using a power source. The work is attached to the cathode, that is a negative terminal of the power source, and the electrode. So, this is the electrode which we are using for welding operation, and this is connected to the positive terminal, that is anode of the power source. The electrode is also having a coating. So, this is the core wire, it may be of same material and it is having a coating. So, this is the coating material. So, this coating material is working as a shielding material. During the process of welding, there are chances of oxidation of welded spots or welded surfaces, and this oxidation is not desired in the welding operation. So, to protect the welded surface, we are using some sort of flux, some sort of protecting material, and that coating of that protecting material is given to the electrode. So, when the joining is getting occurred, the coated material will also get melted, and that coated material will be deposited on the weld material, and it will save, it will protect the welded material from the environment. So, this is the weld metal which is generated during the welding operation. So, we are applying power across, we are applying electrical field across these electrodes, that is electrode lead, and the workpiece is also an electrode. So, during the application of electrical field, there is generation of electric arcs, and that electric arcs are generating intense heat which is melting the electrode rod as well as it is melting the materials. So, when the materials are getting melted, there is a deposition of the electrode material in between the gap of these two materials which we want to join. All the three parts here are melted, the parts which are to be joined as well as the electrode rod which is we are using as the filler material. When these two parts are melted, the filler material will get deposited and it will generate the homogeneous joint if all the three materials are of same type. If suppose we are using a mild steel electrode rod to join two materials of mild steel only, so we are generating the homogeneous weld. All the three materials are same, the materials which are getting joined together and the material of the electrode as well. When we use dissimilar materials for welding, this is also possible. So, here we are using either the electrode rod of different material or the materials which are getting joined may be of different nature, then also it is possible to have the welding operation. The completed welded joint is called as the weldment. So, here this completed welded joint, when we join two parts together, that joint which is completed is called as the weldment. Now, when this welding is getting occurred, so there is a generation of weld bead. Now, let us look at the geometry of the weld bead. Consider we want to join two metallic parts together. So, this is part 1 and there is another part 2 here. Two parts are there and we want to join them together by using any source of heat, maybe an electric arc or lasers. During the formation of the joint, we are getting some sort of geometry, something like this. So, this is fine. So, this much of portion is get melted and there is the resolidification of melted material together and then we are having together unified joint of part number 1 with part number 2, and if we are using a filler material by using the electrode. So, when we try to figure out the various terminologies of the weld bead, so this is weld bead, so this is called as the face of the weld bead. So, there are two base materials, base material number 1 and base material number 2, and when these two materials are joined together, we get a shape something like this. It has a swollen portion at its top, that is called as the face. The point at which the face is getting connected with top surface of metal 1 or metal 2, that is called as toe. So, this point is called as toe of the weld. So, there are two toes, one toe for part number 1 and there is another toe for part number 2. The bottom portion of the weld, it is called as weld root, and the weld root has certain width and it is called as root opening. So, the swollen portion or the portion which is above the plate 1 and plate 2, it is called as reinforcement of the weld. So, this is the reinforcement of the weld. So, this is giving the strength to the weld, reinforcement. If you look at the geometry in much more details about the weld bead, so we can draw another diagram over here. So, we are having a top surface, so this is the top surface of the work part, and let us consider that we just applied an electric arc over the top surface to generate the weld bead. So, we get the geometry something like this. The width of the bead is called as the bead width, here it is mentioned. The sum of the portion of the bead will get penetrated inside the base material. So, this is base material BM and this is called as the penetration of the weld bead inside the base material. So, this is penetration depth. The bead also is having the height. So, this height is called as bead height, and the angle made by the tangent to the face. So, this is the face, angle made by the tangent. So, this is the tangent to the face and it is making certain angle with the top surface of the base material. It is called as theta tau angle. It is designated by using theta and it is called as the tau angle. So, this entire geometry or entire weld bead, it is also called as weldment, and the ultimate objective during the welding operation is to get the ideal geometry of the weldment during the processing. It may be any sort of welding process. Now, after looking at the various bead geometry parameters, now let us see what are the various types of joints being used in the welding operation. Welding is being used for joining two parts, maybe thin parts, thick parts, maybe plates, pipes, rods. So, all sort of materials in any form can be utilized to join together. However, there are various types of joints used in the industry and 5 basic types of joints that we are going to see today. The first important joint is the butt joint. These joints are decided based upon the manner in which these materials are fitting to each other. So, the first type of joint is the butt joint, which is there on your screen. So, here you can see we are using two different parts. So, this is part number 1 and part number 2. Part 1 and part 2 are lying in the same plane. These two parts are lying in the same plane. Their ends are adjacent to each other. We are processing these edges of these ends. We are processing the ends by carrying out some sort of operation, that is the machining operation. We are giving a specific shape, that is a V shape, to create some sort of gap here in between these two joints, and then we are applying the arc energy or the thermal energy which is generated by electric arc or by using the laser here, and by using the filler material we are developing a joint. So, this is called as the butt joint. So, here two materials are adjacent to each other, they are in the same plane. So, these types of butt joints are basically used in fabrication of structures and piping systems. So, these are used commonly for fabrication of structures and they are also used to join the piping systems. So, there is another joint here. Now, instead of having these two parts in the same plane, can these parts may be orthogonal to each other or at a 90 degree with each other. So, consider part 1 is at 90 degrees inclined to part 2 and the part 1 is exactly at the middle of part 2. So, when such configuration is there, then we are calling this as the T joint. If we take part 1 at the edge or at the end of the part 2, so here if we take or if you just offset the part 1 and if you take at the end of part 2, then we can get the corner joint. Again the angle between part 1 and part 2 is 90 degree only. This angle is 90 degree. However, the relation or the position of part 1 with part 2 is different in T joint and corner joint. Of course, the applications are different. So, T joint is again used for the fabrication purpose to join two parts, and the corner joint is also to make some sort of boxes, some sort of closed structures. We are using the corner joints. The T joints are also used for welding tube or pipe to the plate. So, T joints are using for welding tube or pipe to the plates. In butt joint, we require to have both the sheets of same thickness. So, this T2 and T1 are same. So, in this case T1 is equal to T2. Now, consider we are having two different parts of two different thickness. So, consider T1 here and T2, and T1 is not equal to T2. So, when we want to join two different sheets of different thicknesses, butt joint is not sufficient. So in that case we have to have some sort of overlap between the sheet number 1 or part number 1 with part number 2, and then we can carry out the welding operation. So that kind of operation is called as a lap joint, and the filling that we get is of this shape, which can be there on your screen, and this is called as fillet weld. So this is fillet weld. Now in certain situation we are joining the ends of two different parts together. So in the configuration which is there on your screen, so this is called as edge joint. So here part number 1 and part number 2, their edges are aligned in same plane. So this edge number 1 of part number 1 and edge number 2 of part number 2 are aligned in the same plane, and then we are applying the heat energy to melt the material and to get re-solidified and to have a strong joint between these two parts. So this is called as the edge joint. Here whatever the stresses are coming on the weld will get shared. There are various parameters which are affecting the quality of the weld, and these parameters are the rate of travel of the electric arc or the source of heat with respect to the workpiece. It is also dependent upon the deposition rate. So by what rate the material is getting deposited between the two joining materials. Heat input, these are all parameters which are affecting the quality of the weld, and the geometry whatever we have seen is a function of all these parameters. So I will just write over here the rate of travel, rate of deposition, and heat input are controlling the quality of weld. Now we have seen various types of joints in welding operation. Now see what are the various types of processes being used in the industry, and then we will study about the laser welding process. So we will have a quick look at these processes. So welding in broad sense can be classified into variety of classes. There are many versions of classification. Here we will just look at it in a broad sense of manufacturing. When we use gas for joining these two materials, that we called the gas welding. So in this case various types of gases such as oxygen, acetylene are used to generate the thermal energy, heat, and that heat or thermal energy is used to melt the materials. When we use oxygen and acetylene, that is called as oxyacetylene gas, we are generating a flame of oxyacetylene gas mixture, and then that flame will be utilized to melt the materials which are need to be joined together. Instead of oxygen, if we are using simple air along with the acetylene gas, that is called as air acetylene gas welding. Or instead of acetylene, if we are using hydrogen along with oxygen, that is called as oxyhydrogen gas welding. The principle of operation is very simple. You have a mixture of various gases, burn them, you will get a high energy flame, and that high energy flame will be applied at the point of application. Wherever we want to join the materials together, they will get melted and then will get re-solidified, and we are getting the required welding done. If we are using electric arc, we are using an arc during the operation, and that is called as the arc welding. So either we can generate the arc by using alternating current or direct current or we are using some sort of inert gases during the operation that we call the metal inert gas welding. So, in AC or the DC arc welding, we are using a electrode with flux material, either it is coated or an additional flux material for the protection of the weldment that we have already seen in our previous slide. In metal inert gas welding, we are using an inert gas to protect the weldments. So, what kind of gases we are using during this metal inert gas welding? The gases are argon and helium. So, here a mixture of argon and helium is used as an inert gas mixture to protect the weldment, and MIG is widely being used to weld non-ferrous materials such as aluminum. So, non-ferrous materials aluminum. Now, when we are using tungsten, so here this is TIG, the TIG is quite popular in the industry. It is tungsten inert gas welding, tungsten inert gas welding, and here the tungsten is non-consumable, it is not getting melted during the operation. So, in the arc welding, the electrode is getting deposited, it is getting consumed. However, in TIG type of welding, the tungsten is generating the arc only, it is generating the heat energy, and we have to add an extra material in this case. However, the advantage of the TIG is that we can control the heat energy, we can apply the heat energy, we can get intense arcs wherever it is required by using tungsten filament. In this case as well, we need to apply the inert gas, and the same argon plus helium can be utilized to carry out the arc welding using tungsten filament. Then the next one, as far as the arc welding is concerned, is submerged arc welding. So, SAW is acronym of submerged arc welding. Here the electrode is submerged inside a flux material. So, we get the substrate material, then we apply a layer of flux, and then we submerge the electrode inside that, and then the heat energy will be generated by using the spark. During the process of applying the heat energy, the flux material will also deposited at the spot of the application of heat, at the spot of welding itself. So, when we use chemical energy, the heat energy which is generated due to the chemical reaction, that is called as the chemical welding, and very popular and useful chemical welding process is thermite welding, which is popularly used or very useful in joining the rails which we are using for locomotives. To join the rails of the locomotives or train, we are using this thermal welding process. Now, how does it work? So, here we are generating a thermite reaction. So, this is thermite reaction is occurring when we are using two different materials, and these two different materials are metal oxide and iron oxide. So, when we have the reaction between metal oxides and iron oxides, an intense heat get generated. So, this is leading to intense heat. However, this intense heat is localized. So, we are applying it at the required location. Since it is a localized intense heat, it is melting the substrate and then we can have the required joining done. So, this is generating heat and that is melting the interface. It is melting the material portion which are at interface, and when this molten material is getting cooled down, then there is solidification, solidifies, and that leads to the welding. So, this is about the chemical reaction that we use during the welding operation. There are certain processes in which we are not using the material in its liquid form to get fused together. So, here we are using the material in its solid form. These type of processes are cold pressure, friction, we are using ultrasonic energy, diffusion process and explosive welding process. In explosive welding process, we are generating compression forces by detonating the explosives, and then that compression forces are applying on the sheets, and these two sheets are getting together under the action of compression forces and they are getting joined together at atomic level. So, that is the solid state welding. We can apply pressure, that is a cold pressure, when we applied the friction, which is quite popular among industry nowadays, that friction stir welding process. It is a solid state welding process where the friction energy is getting used to join the parts together at a solid state only. When we use the resistance, electrical resistance of the parts to generate the heat energy for joining the parts together, joining different systems together, that is called as the resistance welding. So, this is the resistance welding can be of spot type or a seam type, or we can have a butt type of resistance welding, or we can even have the projection welding as well. So, the details about all these processes, it is not in the scope of this lecture. We have to look at what is the newer technologies being used in the welding operation, and the newer technologies or newer processes are a laser welding process and the electron beam welding process. So, during the application of all these different types of energies for joining the material together, they are having inherent limitations, such as it is difficult to join two materials which are of dissimilar nature, they are not similar. Second, there is a problem of high heat affected zone that we call HAZ. So, that high heat affected zone may lead to more cracks, and some of the welding processes are having many welding defects as well. So, to minimize the welding defects, to minimize the HAZ and to join various materials of different nature, newer processes are being used, and one of the process is the laser process, where we are using laser power or laser beam to generate the thermal energy which will be used to join two parts together. There is another process, that is electron beam. So, high speed electrons are impinged on the work part, and the kinetic energy of these high speed electrons will be converted into thermal energy, and then we are using it for the actual joining operation. However, the scope of electron beam is low because the energy required, specific energy consumption as per as EBM is much higher, it is very high. However, in laser beam operation, which is very common, and nowadays we can have lot of lasers available with us, and as far as the conveyance is concerned, and we have seen many advantages of lasers in our previous class. So, all these advantages are getting carrying forward for this important application of lasers in welding as well. Fine. So, this is again a summary of the various energy sources. So, as I mentioned, chemical, gas flame based energy, electric arc, which is again further converted into thermal energy, laser, here we are using the photon energy, we have already seen that, electron beam, high speed electrons, and kinetic energy of the electrons. And friction, again the thermal energy which is generated due to the friction, ultrasound or ultrasonic vibrations are also used. Now, let us see how the lasers are useful to join the parts together. So, laser welding process is a very simple process. Here we are joining two different parts together by using the heat which is generated by lasers. We apply the lasers at the location of the interface of two parts, and by using the photon energy which is converted into thermal energy at the laser material interaction site, we are melting the work parts. Some portion may also get vaporized, and after melting and vaporization there would be re-solidification of the melted parts, then we are getting the required welding done. So, as we know that the lasers are providing us concentrated heat source. So, that is the peculiarity of the lasers we are using over here. We are getting the controlled energy through collimated, coherent and monochromatic beam of light, and then by using this concentrated heat source we are joining thin metals. Even we can join the thick materials as well by using the keyhole based laser welding, we will see in our coming slides. So, thicker materials also can be joined. So, to get the thin material welding, we have to control the welding speed, we have to control the interaction time of the laser with the workpiece. If the speed is low, then there is a chances of having cutting of the thin sheets, will not get the welding done. There may be vaporization and the thin sheets may get cut, they may get separated, they may get parted off. So, we have to increase the speed of the laser material interaction, so that there should be enough heat that is transmitted for only the melting operation, not the vaporization operation. In thicker material, it is other way around, we can have low speed of operation, so that more energy is put in to get deeper welds. We have to reach in a deep during the thick metal laser welding process. A typical laser machine or a typical arrangement of laser which is used in welding operation can be seen on your screen. This is ruby crystal laser. So, ruby crystal is a solid state laser medium. So, this lasing medium is solid state. We need the excitation source. So, here we are applying excitation energy through flash lamps. These flash lamps are getting energized by using a power supply and capacitor. When we apply the photon energy, when we apply the light energy on the ruby crystal, then the laser beams are getting generated, and these laser beams are getting reflected by using a pair of mirrors. So, if both the mirrors are of 100% reflectivity, then we will not get any output. So, deliberately we are making one of the mirrors partially reflecting. So, when we use such kind of mirror, we can get the laser light beam. So, we are getting the laser light beam, and these laser light beam, then we are focusing on the work part. So, these are the two work parts which are placed very near to each other with certain geometry at their ends. When we apply the laser beam energy over this interface of these two work parts, part 1 and part 2, this portion will get melted and then resolidified. So, in this way, by having a concentrated heat source which is generated due to the laser beam, we can join these two parts together, and for this purpose we required a laser machine, we required a power source. So, this is the power source or power supply is essential. The laser machine, all these parts are required, the ruby crystal or any lasing medium. CO2 is also being used during the laser welding operation. So, gaseous material or the